Guys, welcome to my channel w.r.t. In last video, we have studied about Newton's second law of motion, where we try to quantify force as product of mass and acceleration. In this video, we will try to understand a new concept called momentum, and we will try to define Newton's second law of motion in terms of momentum. So, what is momentum? Let's try to understand the concept of momentum from a very simple example of a collision. Imagine a boy having a book on his head. Do you think it will hurt? Probably not. What if I drop the book on the head from a height? Do you think it will hurt now? Probably somewhat. Now let's repeat the same experiment with a heavier brick. What if I drop a brick from the same height onto the boy's head? Will it hurt? Of course, yes. Will the book or the brick will have a greater impact on boy's head? Of course, the brick. From this example, we intuitively understand that the effect of impact is larger if the object is heavier or if hits the head with a much larger velocity. Now take another example of a bullet. Bullet is very light. What will happen if I throw the bullet on you? Probably nothing. But what will happen if I shoot the same bullet from the gun? You will get seriously hurt. In this example, the impact of collision is higher because the velocity is much higher. So, from these two examples, we understand that mass and velocity are the two most important attributes to study the nature of impact. With this, we will introduce a new concept called momentum, or more specifically linear momentum. Momentum is a quantity which is a product of mass and velocity. Momentum is a vector. It has magnitude and it has direction. At any given instance, the direction of momentum is the same as the direction of velocity of the object at that given instant. The unit of momentum is the product of unit of mass and unit of velocity. Hence, we can say that the unit of momentum is kilogram meters per second. Newton's second law of motion states that the net external force on the object is the product of mass and acceleration. Now we know that acceleration is the rate of change of velocity. If we combine these two equations, we will get force, or more specifically net external force, as a function of momentum. Now, formally, Newton's second law of motion can be defined as the rate of change of momentum is directly proportional to the net external force on the object. Momentum is a very important concept in physics, and we apply it in our daily lives, particularly in sports. Have you ever seen a fielder taking a catch? If you carefully notice, the fielder pulls his hand back during a catch. Doing this allows the ball to slow down at the time of impact. Hence, we can say that the rate of change of momentum of the ball is slower. And as per Newton's second law of motion, the net external force exerted by the ball onto the hand is lesser because rate of change of momentum is slower. Now, we will go to the next important topic where we will study the law of conservation of momentum. In previous video, we have studied Newton's third law of motion from an example of book kept on the table. We studied that the book exerts a force on the table which is equivalent to the weight, and the table in turn exerts a reactionary force on the book which is equal and opposite to the weight of the book. In this example, both book and table are at rest. Now, we will study interaction between two objects where at least one of the object is in motion. Consider an example of striking a coin from the striker in a game of carom. In this case, the striker is in the motion and the coin is stationary. Now consider another example where a cricketer or a batsman hits the ball with a bat. Here, both bat and the ball are in motion. The law of conservation of momentum allows us to study the behavior of interacting objects in motion and provides us a rule that shows the relationship between the momentum of interacting objects before and after the collision. According to the law of principle of conservation momentum, if the net external force on the system of objects is zero, then the momentum of the system of objects is conserved. That is, momentum of the objects before collision is same as momentum of objects after collision. Following conditions are required to apply law of conservation of momentum. We should have an isolated multi-body system. The net force, external force on the multi-body system should be zero. There should be very short time interval between the collision. And fourth, the forces involved, or the only forces involved, are the internal forces. That is, the action-reaction forces between the interacting objects. Consider a two-body system as shown here. Here, we will assume that the ground is frictionless. Also, in this setup, there is no net external force. The weight of the objects, which is the ball here, is balanced by the reactionary force of the surface. Hence, the only force involved here is the internal force of the interacting objects, or in this case, the interacting balls. In the first example, the red ball, which is a heavier ball, collides with the blue ball. As an effect of collision, the blue ball accelerates. The reactionary force of the blue ball slows down the red ball. In the second example, the lighter blue ball accelerates the red ball. But here, the reactionary force from the red ball reverses the direction of motion of the blue ball, or it reverses the direction of velocity of the blue ball. Let's try to understand this behavior from the principle of law of conservation of momentum. We will introduce 6 terms. Let mr and mb be the mass of red and blue ball. Let ur and ub be the initial velocity of the red and blue ball. Let vr and vb be the final velocity of the red and blue ball. Here, the total momentum of the system before collision is the momentum of red ball before collision plus the momentum of blue ball before collision. So, the momentum of the two-body system before collision is mr ur plus mb ub. Similarly, the momentum of two objects or two balls after collision is mr vr plus mb vb. So as per principle of law of conservation of momentum, total momentum before collision is same as total momentum after collision. So we can say that mr ur plus mb ub is same as mr vr plus mb vb. So we see that principle of law of conservation of momentum establishes the relationship between velocity of interacting objects before and after collision. With this, we come to the end of this class. Hope you have understood the concept of momentum, the concept of conservation of momentum, and you are able to define Newton's second law of motion in terms of momentum. Hope this gives you enough foundation to solve numerical problems that involves interaction of a multi-body system. See you in the next class.